Alrighty, we're on.
Yeah.
So hi everyone, welcome to the GST meeting. It's been a while since we've had one, and I figured that today we could talk about ONOS scalability. In the past, and up to this point, we've been doing a very good job at testing performance and making sure we don't have any regressions in performance. And although there is an element of scale to the performance test that we do today, it's really not, at least in my opinion, doesn't qualify as a scalability testing. And I know that we have some specific requirements and hitting some ceilings with memory utilization in one of our deployments. And so this is a good opportunity for us to figure out what how to approach this and what we should do in terms of instrumentation tests, debugging, and so I'll just leave it up to that, kind of open it up for general discussions.
So I guess from what I understood from the performance measurements, we use the null providers, and we push a lot of flow rules through the system, right? Hundreds of thousands of flow rules through the system. But we've never actually tested what happens when you actually store that many flow rules in ONOS for an extended period of time, right? So my understanding is that you've pushed thousands of flow rules, then you've removed them and pushed again and removed them and so on. So you're testing the throughput of going through ONOS down to the switch, which is a null provider. But you actually haven't tested, what happens when the flow store has to store 100,000 flow rules or 1 million flow rules, right, and so on. So that's one aspect, right? Another aspect is that in this one of our deployments, you can imagine that there's 100,000 routes. Now, route service used to be part of the core, but now it's like an app, right? And the app has its own store, and you can imagine there's 100,000 routes in that store. But those routes then become flow rules in maybe, say, 10 switches. So those 100,000 have now become 1 million flows because we store all the flows for all the switches, right? So the question to ask at this point is that, do we need to store 1 million flow rules? Is there a way to shrink that? I don't know, some clever way, or given that you have the routes, we can't get away from not storing the routes. So the route service has to have the routes in the route store, but flow rules, because they can always be recomputed. So do we add the option to make the flow rule store stateless? And what are the implications of that? Then the third aspect is that we do store flows in the flow rule store for a certain purpose, right? That we want to see that it matches the state that we believe is in the switch, right? And we periodically poll the switch to see what's in there, and then we do a comparison. And following that comparison, we figure that the flow rule has been added or in pending add state, or it's missing, so we add it again, and so on, right? So it does serve a purpose. However, does this purpose scale, right? How often can we really poll the switch for 100,000 flow rules? And if we can't come up with a more clever statistics collection algorithm, if you wish, then what's the point in storing all these flows in the flow rule store? So is there a sophisticated statistics collection algorithm that will still serve the purpose of the original intended purpose of the flow rule store. So there's three different questions that I'm posing, right? How does the store behave when it's very big? Two, do we need to store, if given that the route store is already storing the routes, do we need the flow store to stay all of this multiplied by the number of switches? And three, is there a more sophisticated flow rules, flow statistics algorithm, collection algorithm that still meets the objective that the flow rule store was originally designed for? Right.
So on the last point,
Yeah.
I was under the question that the flow statistics algorithm that we have right now doesn't just hold everything every time, right? I think it has more fine-grained mechanisms to hold, various. It's I don't know exactly how it works, but it holds some of the flows at some periods of time, right? And once it's sure the flows are there, then it holds them a longer intervals. So it's not just like every single time a time applies, read everything and then check.
No, you're talking about this adaptive flow something. I thought that was disabled by default.
It's disabled by default because somebody detected some problems with it, as far as I remember. But I don't keep track of these things.
Yeah, but the main idea of that adaptive flow collector or something is what you say, that if the flow has been stable for a very long period, then we probably don't need to hold it very frequently, right? So if the flow change frequently or change in a very short time, then we probably need to monitor that flow more frequently than other flows. So that's the main kind of concept of adaptive flow collectors, but I don't think we enable that by default right now.
I guess from my viewpoint, I would try to separate that sort of behavior from the scalability. Although clearly having more intelligent behavior could significantly contribute to improving the scalability. But right now, I guess I was just thinking that we would focus on measuring what the scalability, quantifying is where the scalability limits are, and if rather than, at least initially, rather than sort of drastically changing the behavior of the flow rule subsystem, what we could potentially investigate would be offloading out of memory the flow rule store. For example, we could offload it up to disk, right, and then have some caching mechanisms to reduce the stress on memory, if that's indeed what the performance or scale limit is.
No, this is the issue 1 and 2 Stark mentioned, right? But I don't think we can ignore number 3.
The collection.
Yeah.
So what scalability limits are you hitting right now? Do you have an idea?
No, we've never tested it.
Right. So this is
one of our deployments. They are hitting a problem.
Routes and potentially times 10 flows. Right?
So
yeah, but they're hitting a problem at 10K or 20K routes.
So
Our route crashes.
Out of memory.
Yeah. My thought is this. I think what we ought to do is just measure it, so that we can sort of understand where the limits are and then focus on some of the
But at least
areas.
we should be able to kind of have a rough idea about how much memory we need in order to keep a certain number of information. For example, how much memory if we need to store, say, like 10K routes and maybe 100K flows, something like that.
That's exactly right. Just to quantify the behavior of the system as it is right now, then maybe we can understand where some of the major offenders are and focus on those. That was precisely why in the last couple of days I was enhancing the null provider subsystem to allow us to more efficiently create large, kind of faithful simulation of the access network. And then in terms of memory consumption, it's still the same. You don't have to have a very large environment physically. We don't really care about this environment passing data. We really just care about exercising the control channels and putting stress on the system in terms of the number of entities it has to keep track of and manage and purge and whatnot.
Yeah, but that only target issue 1, right?
No, absolutely. I completely understand, but I think we need to have something in place to do this so that we can observe the system evolving towards improvement, hopefully, right? We need to have some sort of a way to measure it, because if we don't, in my opinion, then we can quantify what the what the behavior of the system is and what the bottlenecks are, and we cannot also quantify what the improvements are over time. Which is why I think start there. That's precisely why. So right now I actually have a good way to faithfully simulate that access network. Next step was going to be, this is without segment routing or without flow rules. But I would still, just like in terms of the topology, I would like to see what the footprint of the topology data is in memory, and be able to quantify that. The next, after measuring that, I was thinking what we would do is layer the segment routing application on top of that.
What kind of topology information you're looking at, like links, devices, hosts?
Yeah, exactly. Ports.
I would imagine that would be dwarfed by the flow information.
I would imagine so too, but I don't want to overlook some.
Yeah.
Obvious, yeah. I mean, clearly, in terms of the devices themselves, it's very small.
Yeah, the devices.
We're talking about like 14 devices, right?
Yeah, and the links are probably
So
also a very small number.
Exactly.
But the hosts could potentially have more, maybe hundreds, thousands of hosts.
Correct. Yeah, probably close to 10,000 hosts.
Yeah.
Right?
But still, I think I also agree that comparing with the 1,000 routes we're going to host, that
Yeah.
host
So
is probably not a big portion of it.
Right, but yeah, I agree. So after that, the other idea is to layer the segment routing application on top of that, and basically configure to behave.
Actually, you don't necessarily need to layer segment routing on top of it. You just need to inject random flows and routes.
You think that that's enough? And
Yeah. It doesn't.
Well, the route
store,
store exists separately from segment routing.
It's separated.
Yes.
It's a different.
They're separate, and the segment routing app in itself does not store a lot of state.
Do we have any test tooling to be able to insert routes?
REST APIs, but
Yeah,
I
I
think-
prefer not to use that because I want something that works fast.
Yeah, actually, there was a story to make a bulk REST API route store addition. Right now, you can add only one at a time. So we have a tool that actually the operator created, which uses that REST API one at a time to push 10,000 routes.
We can certainly improve on it, right? I would like something that we can bring up fairly quickly.
yeah, but even adding that one by one, it should still work, right? Just
It does
a bit of time
work.
for
So
it.
they have found that 10,000 routes is okay with a multiplier of 5. So 5 switches, so it's 50,000 flows.
Yeah.
But when they go to 20,000 routes, it crashes, right? So
And crashes without a memory.
is it? Are you sure it's out of memory, or it just becomes completely unresponsive? I thought I remember hearing the unresponsive.
I was responsive to one of them, but I also think there's an out of memory block. But well,
That's the question of how much like queue size do they give?
8 gigs.
They give 8
gig.
or 16. 8 or 16.
8, 16, maybe 8, maybe 8 gigs.
So
But I have an impression from, remember a long time ago we deployed SDNIP somewhere, and I have this impression that 8 gig of memory is
Not enough.
No, it's not. Which are you?
I mean, with today's architectures, I think we could certainly ask for more.
Yes.
But I don't want to just necessarily rely on that. At least if you understand what the footprint is, then you should be able to kind of plot for this many flows. You should be able to have, or many routes. You should be able to ask for this much memory.
It should be
have some sort of
it should be linear, right? To the
Somewhat,
number of somewhat, or maybe at least positive relationship with the number of routes we put in the system.
Right, and I guess the reason why I'm thinking we should invest in kind of having this simulated and empirically measured is because it'll make it really easy to pass down to QA for then periodic execution, just like we ran the performance tests today and provide metrics on them. We should be able to provide some sort of metrics, maybe in terms of memory footprint on and see how our consumption is
CPU usage.
The CPU usage, exactly. I don't know exactly what, but some sort of metrics of the system that would help us evaluate the at certain level of scale what the behavior is. Or potentially, just like today we measure in multiple different cluster sizes, we could potentially measure the behavior of the system at a couple of different scale points, just to kind of give us a plot line. That was what I was thinking. So okay, so that's good to know. So you should be able to just insert routes, and then the routes themselves get transferred into flow rules.
No. In order to make routes into flow rules, you need some routing app. But I'm just thinking that maybe you don't need that. You can probably find another tool to just inject.
I mean, you're using fake switches, so you might as well use a fake app
that generates fake flows.
Maybe.
There's a demo install, some demo app that installs flows that we use.
Okay, so as long as
just some fake flows.
As long as we have base, and it doesn't really matter what flows they are.
So I think the flows will the size vary in terms of how many hits.
Which is why exactly what I'm asking, right?
Different selectors.
Yeah, they will, right?
Maybe yes.
Yeah.
So I would like to create something that reasonably, somewhat, faithful to what the segment routing app is doing.
Okay. So
the most is very simple, right?
Yeah,
It's just ETH type and IP dest. That's all it is, right?
Yeah,
right.
Flows are not all the same, right? You can't just say 10,000.
But most of the flows that's causing a problem right now is actually
This is the largest one, right?
The routes are just matching the ETH. Does it even match on ETH type? I can't remember.
Yeah.
Maybe ETH type and IP dest. Yeah.
Okay. So
So treatment is probably a group, right?
If you create, just like we have the null provider and the ability to create a custom topology, then maybe we can add sort of null simulators to be able to inject routes and flows, corresponding flows, or even just routes, and from those generate fake flows across the devices.
So
that should probably be
maybe
better.
also the bridging flows match on MAC edges.
Those don't scale.
Those are just 1,000 maybe
It's also maybe
per switch at most.
Yep.
But 1,000 versus 100,000 is a huge difference. We could, but it's not a big deal. I mean,
Yeah, I still think the bottleneck will be the routes.
Okay, so my thinking is that if you create something that creates the routes, makes it easier to
that will be good
test at a high level,
that
and
will
then
be
have
good.
a fake
Yeah.
translator from the routes to something
Yeah.
that reacts to the route being added and translates it into some fake.
I can actually give you an example. Like if I have a route, then what the flows corresponding to this route will look like.
Perfect. So I'm gonna hit you up on that maybe tomorrow, and then because I'm at the point where I'm reliably creating very, very large network that resembles the access network of the provider.
Very large, I mean topology-wise, right? I mean
Host-wise, yeah. It's the topology-wise. I mean, it's still primarily just 2 spines, 2 pairs of leaf switches, and 8 access leaves.
access leaves.
And it's
Many hosts.
And many hosts only access leaves. The pairs of the leaves, the leaf pairs, have dual home hosts on them, right?
Yeah.
Right.
And the access leaves have very high number of.
What do these hosts do?
Well, right now they're simulated, right?
They are discovered by ONOS. For that to be discovered, the host would have to speak.
No, it's not.
It's injected into the host.
It's
It's
injected.
just injected.
Yeah.
Because remember, this is
That
no
is
data
okay.
plane. This is just
That's
yeah.
That's fine.
No, but for the host. Oh no, never mind. Yeah.
That's fine.
Just think about
We should see if the host store can handle, 10,000 hosts. That's fine. But the real problem is going to be the flow store, right?
Right.
So, and the route store. Right?
Yeah. So this is just an example of a screenshot. It's not showing up. Oh,
Are you
Are you-
connected?
I thought I was. Anyway, it's not that important, but right now I just created it with like 10 size. It's only 100 hosts per access.
Well.
It's 100 hosts per switch. Okay.
Switch.
Yeah, and then what you see on the interior, the 2 nodules are the multi-homed hosts which are connected to each of the leaf.
Is the UI still responsive?
What?
Is the UI still responsive under
Yeah.
this amount of?
Yeah.
Yes.
Well, remember, Turk Telecom did something with like 20,000 nodes.
Okay.
It's fine. Anyway, so I think the next step will be then to insert route store, entries in route store, and have some more fake population of the flow rule store, and I
yeah.
think then we can measure it.
Yeah.
I think after at least come up with a characterization curve of what it is where we should ask for in terms of memory. We can map it to heap size as the number of entries grows. That way we can provide it as a formula for recommendation.
At least a projection of
for now,
how much-
without actually making any code changes. And I think the next step after that would be to see what would be, is there any sort of low-hanging fruit where we could start shading of memory, offloading to disk, and other sort of more advanced.
Yeah, we should also have some kind of
optimizations.
profiling that tell us like which part eat up all the most of the memory.
Exactly, yeah, and which is why I'm thinking starting a little bit small so that you can see and have to figure out. In the past I've used JProfiler, but it would be nice to be able to use something more automated to be able to potentially again automatically harvest that data.
So at that point, it would seem like the logical way to think about it is that, okay, so let's say 10,000 routes become 50,000 flows, and the system seems fine. And then we put 20,000 routes, and that becomes 100,000 flows. And okay, well, the system has some problems, but we do a few things, and now we are okay with the 100,000 flows. Then you keep going up, and then you have new problems, and you try new things, and it still gets, okay, you can meet the next level of, you push that, scale limit further and further by doing tweaks. And that is one way of thinking about it. And then another way to think about it is what I was saying is that, do we even take the hit? I mean, are we trying to solve a problem which can be solved by just thinking that, well, what if we don't retain? Because ultimately the goal we're trying to hit is 150,000 routes. And even over 10 switches, that's 1.5 million flows, right?
Yeah.
So you can keep pushing the boundary, 100,000 flows, okay, it crashes. Okay, I fix something, it becomes 200,000 flows, but then it crashes. And then we keep working, we slave for 2-3 months, and then the most we can get to is 500,000, and then it's going to take a lot more to get to 1 million, and then 1.5 million. So you might also want to think through, is it worth it?
I mean, so the thing is, okay, I think if you have a way of measuring it, we need to have a way of measuring it, right? The behavior of the system, right? So figure once we have that, and I think we can attack at least go a little bit in attacking some of the low-hanging fruit. But I completely agree that if you were to sort of sequentially keep pushing the barrier without, especially as we start to hit more and more resistance, as it gets more difficult to optimize the system, we definitely need to be on the lookout for that. I completely agree, and I think we could at the point in time where we sort of address the first low-hanging fruit, then we can sort of take time out and maybe introduce try to go for a test where we have the sort of end goal. What does the system completely collapse the end goal, or can we achieve the end goal with something like what you said, having alternate mode of behavior where we don't store the flow rules, and so basically we can drop this notion of authoritative flow rule store.
Yeah, that's going to have its own problems.
No, I understand, but I mean, we should definitely think. You're right. We should definitely think about what it would involve, but I would like to minimize the impact on the existing applications. Potentially have it sort of selectable behavior.
Yeah, it's an option, right? I mean, I'm not saying change it for everybody, but in a certain deployment, it could be an option.
It's a trade-off
to turn it off, and then we deal with the repercussions of that.
Turning off means that just not storing the information.
Say you don't store it for a certain table.
Okay, for a certain table, but
yeah.
Do you also mean that you don't sync information with this?
Yeah, we don't. Yeah. We don't store. We don't sync.
It's fire and forget. I'm pushing this down, but I'm not going to be asking what's there, and I'm not going to be reconciling.
So you're saying that you don't even want to have adaptive flow collector?
No.
Because I mean, even collecting a larger number of entries in itself might be a performance problem.
Yeah, right. So that's right.
I mean, it might collapse. I mean, even if it's not a problem for ONOS, it might collapse the control channel on device.
Yes. And in fact, it might, we've seen this before, it might hurt the like more important stuff to go through the same channel.
Exactly.
Right.
Clog up the
Clustering clogging it up.
Yeah.
Your links are not getting, your LLDPs are not getting through, so your links start timing out. Okay, that's a problem.
Yeah, I mean,
So-
we've talked about that before, right? With I mean, it was with Ali still, where some devices you ask them for flows once and they blow up because the agent that's cooking the responses is not capable of dealing with the number of flows. I mean, initially we were able to get away with it with small ACL sized agents, but if you get now open up the hardware tables which can hold a large number of entries, it's going to be a problem.
So does that also mean that we're going to give up entirely the knowledge on the data plane? We no longer have idea what's installed on the switch
Yeah,
anymore.
so that's the thing, right? So that the net result of it is that there are other problems, right? So can we start thinking of how to get around those other problems, right? Maybe you ask on that particular table, you ask the switch in patches.
Or only update specific flows every time and try to.
Well, this is where things like GNMI and the event telemetry stuff would come in, right? Where we can start measuring. We can first of all move more towards kind of notification or streaming based model of what's on a device.
Yeah, I mean.
Well, but that's a very different story. Right?
Yeah,
that's a very big change from the on the
But that
agent
requires a change in the switch.
The agent
No,
side.
I
We
understand.
can't change that.
I understand that, but
Yeah.
I mean,
Agreed. So I find the approach is fine. It's just that we doesn't hurt to think in parallel that if we did make the store stateless, I mean, I'm fine trying to push the scale over a few months to try and push the scale, but if after 3 months we find that there is a certain limit beyond which we can't push it, and then we have no backup.
oh, I would hope that actually, I was imagining even much less time.
Yeah.
Even much less energy on it. I mean,
Okay.
the idea is, yeah, have structure in place, measure it, optimize the first round, and see how that goes.
Yeah.
And then if we hit a lot of resistance,
I think it should be okay if we spend 1 or 2 weeks just to at least have the projection of how much memory or resources we're going to need in order to reach that certain level.
Okay, and it's a good idea to just do it using fixtures. My original thought was I was just going to present the null topology to the segment routing application and then just let it run. But if it's easier to actually get it done with the simulated
Yeah,
then it's better.
There's nothing wrong with putting it to segment routing application, but then it comes with other baggage. You'll have to do configuration and stuff and get the configuration right, and
Right.
it's not necessary.
Yeah, if that's a great point. And I'll make it more portable too. That's sort of the approach.
And
Because if you need to simulate
yeah.
something else, we can simulate something
Yeah,
else.
it also add more variables into your test environment, right? Segment routing itself is the variable. It could
But it
be
doesn't-
other overhead
But
with
from a
a
state perspective, it's not, right?
from
It
the what?
doesn't retain any
So
state.
from what state
From a state perspective, from a scale perspective,
scale?
is not a problem because the app itself does not retain any state for flows or routes.
Yeah, but still some next objectives, right?
Yeah. So, any questions on why we're doing this, or anything you think we have not thought of, like those 3 issues I mentioned? Anything else?
Continuously measuring the system state of the ONOS instances with certain load, we might need more hardware resources, right? Our current bare metal service, which runs 90 performance tests, they might not be able to run that because we only have the day time to.
Yeah, I mean, so noted. Yeah, we'll have to figure out how to either sort of time share the existing resources, either reduce the frequency of running performance tests.
But I think there are new servers coming too. So the ones that are meant to go to Flex, I don't think we need all of them there. So I think I could find some resources from it, hopefully. But, no.
And so yeah, clearly one thing is that then now that you mentioned the bare metals, this might have actually additional dimension because with performance tests we're measuring the dimension of the node clusters, the cluster size in terms of the nodes. Here we may need to do that as well, right? Because clearly measuring just as you need to probably measure on a single node, then 3 and 5 and potentially 7. And then there is also the data points as the size of the environment itself increases. What the footprints are. I don't know. There may be. I may need to talk to you when we get to the point of trying to hand it over. I think.
So you mean the same number of routes, so to speak, but on one instance versus 3 instances versus 5, depending on what kind of partitions you're doing and all that.
Exactly because of replicas, because different size
Exactly.
clusters have
Right.
different numbers of replicas, so
Right.
there'll be more memory used in larger clusters.
Yeah. So that's a 4th dimension.
Right.
One thing I think is that flow is sort of playing the common abstraction of storing flow. So if we were to make that flow stateless and derive that from the route subsystem, so for every application, we need to come up with some kind of mechanism that will derive the whatever that's persisted to the flow rule. So, and initially, I guess intent was meant for that, but that didn't meet your needs. So as a result, you guys are directly interacting with a relatively low-level abstraction of flow configuration kind of thing. If we were to take flow rules layer as persistent layer out, do you think there's a way to fill the gap that intent framework was missing, or do we need to come up with something?
Yeah, what you're saying, because right now we have the route store, and then the Silverlight app takes those routes and transforms them into flow rules in a particular way, right? Which may not be the same way that other applications transform routes into flow
Well, it's
rules.
analogous. In principle, it's analogous to what the intent is doing, right?
Right, but I think you're just saying if we ever wanted to reconstruct that state of the flow rule store, if we don't store them, we need to ask the same writing application, how did you get your flows, right?
Yes.
Or what
Yes.
the flows are.
Yes.
So, but that's something that has to be done to every single application. It's application specific as to how you transform things like routes into flow rules.
Yeah, but that's why I was saying, right? This making it stateless is an option.
Yeah, exactly.
So if some other application and some other solution need not make it stateless.
Of course, that might affect coexistence, right, of segment routing and some other app. But
Yeah.
which may be not an issue, but I think we can explore different options, right? Because we can, for example, make it still persistent, but maybe does not occupy a place in memory. And we make the polling of the statistics optional, then we minimize the churn in that, but still persistent, right? You can still ask, what are the flows on this device, flow rules on this device in this table? You can still get an answer, but it doesn't need to hog the memory if it's not necessary. So I think we can explore, I think, different options to try to minimize the impact of the existing applications.
Yeah, that seems like it's the simple short-term or simple solution is persistence. There are some less like object-structured merge trees, data structures for disk that you can store flows on.
So we're not looking at flows changing in a very high frequency, right? The flow could come in the burst at the beginning of the system startup, and then all the routes and flows should become somehow very stable, right? So it doesn't require a very efficient read-write from.
Exactly, especially if you're going to suppress.
If you lost an upstream router or something, and suddenly your million routes that can change to the next tuple.
That's why we have the option
upstream is
router,
not
right?
so much. It doesn't advertise that much.
Yeah, it actually advertises the route.
It's actually from the access side. All of these routes are
Yeah, the access side.
subscribers.
If you lost a leaf switch, is this an event that
It-
would cause?
Yeah. So
could be,
I'm not
yeah.
saying it should be completely zero. I'm just saying we can come up with a number of per second bursts. How many routes change per second. But it's certainly not going to be the full 100,000 routes changing per second. So maybe, I don't know, tenth of that is a safe number to assume. So if you can do 10,000 per second, but again, this is on routes. So 10,000 routes per second change does again get amplified by the number of switches becoming flows. So yeah, that's.
I'm sure the trade-offs will be involved, right? We'll have to evaluate them when we structure the implementation.
Yeah, another aspect is that can we even handle that much of route and flow change in a sudden? For example, if I lose a leaf switch, I may need to reprogram thousands or tens of thousands of flow on the other leaf switch. Is the app capable of doing that? That's maybe another thing.
Okay. But the approach overall sounds reasonable. Okay. What do you think, Brian?
Hey Thomas, can you hear me?
Yep.
Sorry, it's been a little bit difficult to follow the conversation remotely.
Okay, no worries. I just want to make sure I give you an opportunity to pipe up.
Yeah, I think I'm gonna have to review the material later with some of you guys. Sorry.
All right. You can discuss it in Rose and Crown, maybe.
You shouldn't have gone. You two shouldn't have gone so early, right? Now we'll have to come and catch up.
Now I understand why it's hard to follow.
It's you know, just got a 5 o'clock somewhere right here.
All right. Well, thanks.
I'll be back in a little bit.
All righty. And so in terms of where are we going to run it to get back to that point, I think we can set out when we get there. Yeah.
So now that we feel RC6 is, we've fixed a lot of the issues that we have seen in the last 2 months, and it's more stable. Now the ISSU and scale stories are going to start coming. It's already started coming.
Right.
Right.
Right. And quick question: where do you see them in terms of relative priorities, ISSU versus scale? Both number one.
Wanted both yesterday.
Yes.
Right. Honestly, I think pain-wise, they would prefer to lessen pain. They would prefer ISSU first
Because that makes
because you know when you put it out.
Mm-hmm.
When an architecture team puts it out to the operations team, and then they don't have access anymore to what the operations people are doing, and the operations people start complaining, it looks bad on the architecture team, right? So they would want to have this to lessen their pain, right? Scale is something where they will eventually get to, right? I mean, right now they're not doing 100,000 routes, right? They're just preparing for the time when it will come to needing 100,000 routes. I get the feeling that we have more bandwidth when it comes to scale, and lesser when it comes to ISSU.
Well, that makes sense. We should probably prioritize accordingly. I think it actually works out because I can Jordan can drive the ISSU side of things, right? And there's few kind of remaining tasks that need to be done on 12 and the flow store, right? And I can drive the simulation, at least the scale simulation side of things, and kind of in parallel and opportunistically.
Yeah, I mean, the good thing about ISSU is that it's at a place now where it's just a matter of us getting a lot of use out of it and fixing bugs to make it, just to increase confidence that when we give it to someone, it's actually going to work.
Right.
That's all that's being done now. So that's some little tests.
Well, great.
Yeah, and I'm getting more help there, so.
I saw that there was somebody already starting to ask about it.
Yeah, we have a couple of people come in to help.
Oh, sorry, Bob. I just noticed your message. You had a comment?
Yeah, I had a ton of comments. It's just hard to participate remotely because there are no breaks in the conversation, and every time I get ready to talk, somebody else starts talking. So I don't want to interrupt you guys. But anyway, I just wanted to say that I like a lot of the stuff that Thomas was saying. I'm a big fan of null provider, although I'm not actually an expert on it. I should probably look at it more. I mean, I think another aspect of scalability is obviously generating all these messages from the data plane to control plane and handling them, and handling lots of links coming online and going offline, and topology, apparent topology changes or actual topology changes and things like that. So I assume null provider can do that as well. It may also be useful at some point to do scalability tests with lots of software switches. It's too bad I can't easily help you out, because that's something that I would be able to potentially help out with. That might be useful at some point as well.
So we already do that to a degree as part of our performance tests, where we mutate the topology and are measuring not only the latency of our responses to the topology changes, but also kind of monitoring the throughput of the topology events, how quickly we can recompute intents, and how quickly we can reassemble the graph after the topology changes have occurred. So we measure the rate of things, but we haven't simply done it at large scale, meaning having a large data set in the system, because clearly that large data set in the system will affect how quickly we can do things, right?
Right. So yeah, what I'm thinking about is, sort of modeling a very large network of, I don't know, hundreds of thousands of switches or something with, lots of things happening, and to sort of see how well that works. And I think it may be interesting to look at it from the null provider perspective, but also from actually exercising a more real driver that actually talks OpenFlow to a control channel. And I think there's sort of this interesting intermediate thing of having I don't know what I call like fake net or proxy net, which similar to what's existed for a long time, like the OFLOPs or things like that, where it talks OpenFlow still, or whatever protocol X could be protobus or whatever, but basically sort of faking the data plane but having a very sort of realistic control plane that actually talks to the drivers. I think that's sort of a useful data point, sort of a successor to kind of OFLOPs. You might think of it in some sense. And another thing, of course, is to have an actual kind of hardware multiplier. Take whatever hardware you have and have a lot of software switches on it. So that's something that I had hoped to do with like scaling out cluster edition, but sadly haven't been able to pursue much. But I think sort of all those are interesting potential scalability testing points. Null provider within sort of within ONOS, or sort of a fake network like OFLOPs or et cetera outside of the network or outside of ONOS, and then an actual really instantiating a bunch of software switches. Now, obviously, you don't really care that they're actually shipping data around, but the interesting thing is you're actually talking to something that is sort of more real in some sense, rather than something that's just abstracted. So I guess that's sort of my take on three sort of potentially useful sort of testing methodologies. And also, I think your sort of idea of where you wrote down quantify the resources required to store X number of flows and routes. I think that'd be definitely useful data to have. Is it linear? Is it more than linear, et cetera? What happens, and how responsive is the system once the state gets larger? And I think Saurav's point of how about if we take this completely orthogonal direction and go sort of more stateless? The question is, how much mileage can you get with that, and what really are the trade-offs? Are you losing anything that you care about? Do applications really depend on reading the flow store so that all of a sudden they would, information would have to be recalculated because it's no longer cached, or perhaps even queried from the switches, but OpenFlow doesn't? Well, I don't know, it might be kind of clunky to do that or slow. So I think it's a worthwhile sort of investigation to pursue, like, what are the pros and cons of doing that, and what do you gain and what do you lose? I think it'd be really interesting to know.
Yeah, because while we have the APIs today to be able to inspect what the flows are and to list them for diagnostic purposes, we may not actually have any applications that at runtime rely on that.
Yeah, actually, the segment routing app never actually checks the flow state. Never.
My guess is, like you say, that most of the time it's fire and forget, and we have this synchronization thing where, like, if a switch goes offline and comes back online, then we can like reload its flow table somehow. But it seems like, well, recalculating at that point is probably not terrible. Or although I guess if you didn't have to recalculate it could do it potentially faster, but that might not be the bottleneck. The bottleneck might be flow installation of the switch itself. So.
Yep. And we know for a fact that the pipeliner implementation for flow objectives, the flow objectives are effectively just kind of like a stamp or die from which it's a very short-lived intent effectively for device-centric intent that gets translated in flow rules which get fired and forgotten. So we know that works there. And if a lot of applications already use flow objectives, well then we know that they're not relying on the presence of flow rules being placed.
Yeah, so that's interesting. I mean, if the flow objectives are, I guess it'd be interesting to know, well, okay, so we still cache the flow objectives, but not the rules. Is that good enough, or is that still problematic because there's still the flow rule state is so large or so bulky? I mean, there are lots of other things you can do. I mean, it seems like routes shouldn't really be that large, but I mean, there's this other interesting thing you mentioned, that it seems that you have kind of a route application that's orthogonal that doesn't implement its routes as intents. So that's kind of interesting. And it seems like there might be another way to have routing intents, which would be part of the intent subsystem rather than duplicating its functionality in app. But I guess I don't fully understand the way this is organized. But I think it's interesting that it seems that you have sort of at least two different methods of doing something which seems pretty similar.
All right, well, cool. So I think we're nearing the end of the time that we have. If nobody has anything else, we can call it a day. It was a good discussion. Thanks for providing summaries for them. All right, we'll see you guys next week, hopefully. And if anybody has any topics, I would please strongly encourage you to send them to the TST mailing list so that we can put them on the agenda. Oh, one more thing, sorry, before we end. John suggested that maybe we reduce the frequency of the TST meetings. I think it might be a good idea to bi-weekly. Is there any objections to that? If not, then I'll just modify the calendar in a wiki page and send a message to the mailing list. All right, cool. Bye-bye, everybody.
Thanks.